of our deep learning sessions regarding recurrent neural networks. As we already seen about feed forward networks, back propagation networks, etc. Today, as earlier said, we are moving on to the recurrent neural networks. So I have here given some acknowledgements for the content and images that I have used in this session for uh, further processes. So this is just an outline what all things I have included in this PPT. First, we are moving on to RNN. After that, what are the typical process sequences for RNN? What is the purposes of RNN? What is the working of RNN? After that, we are moving on to the applications of recurrent neural networks. What are the two disadvantages of RNN and what is the solution for that RNN? Then I will give some Keras implementations on RNN applications, etc., so that you will get a hands-on experience on that. Okay, so basically RNN is nothing but RNN is a type of network architecture that can access multiple inputs and that can generate variable outputs. Multiple input matlab various inputs and variable outputs, which contrast with the conventional or vanilla feed forward feed networks. Vanilla feed forward matlab, I mean, it is the conventional way. So we can consider input with variable length, such as video frame, a sentence, a review, a message, etc. And if we want to make a decision upon these sentences or frames, then we will use this RNN. Okay. So, recurrent neural networks, you know about, uh, I mean, whenever I'm talking about deep neural networks, I have to drag our human brain, because human brain is something we can, yeah, we can include with this deep learning, because human brain is having neural networks, right? And a lot of processes are there happening inside the human brain with several neurons connecting with that, and it has its own memory, and it's this all happens in milliseconds, or I mean less than milliseconds. So human brains deals with information streams, right? We will talk each other, and if we are talking each other, we will quote something that previously somebody has said, so that means we have memory. So most data is obtained, processed, and generated sequentially. That listening sound waves and vocabulary sentences, brain signals instructions like sequential muscle movements, etc. So human thoughts have persistence. Humans cannot start their thinking from scratch every second. No need to, right? They have memory and they can code that memory, and from there they can start. The applications of standard artificial neural networks and also conventional neural networks are limited because of some problems. Because it's a fixed size vector as input. Input can be only a fixed size. It's already given from n1 to n2 or I1 to I2, I1 to IN, etc. It's a fixed size vector. This is the standard artificial neural. I am talking about standard artificial neural network. And a fixed amount of computational steps are also there. Number of layers, input layer, hidden layer, and output layer, we have some fixed numbers. But recurrent neural networks are not like that. Apart from that, recurrent neural networks are a family of neural networks introduced, or we have created it for learning sequential data. Sequential data means we can say this sentences, frames, videos, etc. Actually, these are inspired by the temporal dependent or persistent human thoughts. So, which are these sequential information? Which are, I'm already said that sentences, video frames, etc. So, we will see what are the different types of sequences we have. First is one to one. What is one to one? One to one matlab, this is, here is a classical feed forward network. Capturing, we have one input and we expect only one output. Next is one to many. One to many, we can take an example for image captioning. Image captioning means we are in Google, we are giving one image and we need to get a caption or a word or a sentence. So here what will happen, we have one image as a fixed size input, that is one input, and the output can be words or sentences with a variable length, that is one to many. Another sequence is many to one. Many to one, we can take it as a emotion classification, sentiment analysis, sentiment classification. Uh, I mean, where this application comes from, for example, if we are taking a Twitter or a movie review, many of the people will be written in sentences like this movie was a blockbuster. Inside the theater, I was very happy watching in all the movies. So from the all the sentences, the system or the algorithm has to decide, the network has to decide whether that review is a happy review, sad review. If it is an emotion or sentiment, there are many classifications like happy, not happy or sad. It's not binary. We are having surprise, we are having agony, we are having, I mean, different types of emotion. So in that case, we are classifying this variable inputs, variable sentences, that is the variable inputs, into one, what is the emotion, that is here happening. Next is many to many. Many to many, here we can say it as a machine translation, like Google Translate. One sentence we are giving in one language and the output will be given in the another language. So both are in the variable size length. This is many to many sequence. The last many to many is what? For example, if I have a video and I am inputting that video, so we have to process it frame by frame. We have to take decision on frame by frame. So in that case, each frame will be of fixed size. So the input and output will be of fixed variable fixed size, but feed every frame of a video into the neural network, and then we need to expect an output right away. So, however, we can say that, however, since frames are generally dependent on each other, it is necessary for the network to propagate its hidden state from the previous to the next. So here we require the recurrent neural network task. That is, we require some information of the previous content. Sorry. So this is the explanation of one to one, one to many, many to many, and the last many to many, etc. This we have already discussed.